Welcome back to Josh Does Math. Today we're going to be working with the higher order derivatives. So those are the derivatives of derivatives themselves. So right here we have two functions and we're looking at the first four derivatives of these functions. So for the first one here we'll say y is equal to 8x minus 3. So in this problem they're asking what's dy dx, what's d squared y dx, the derivative of dy dx, and then what are the further derivatives, the higher order derivatives, as you just keep taking the derivative of your derivative. Well, dy dx, that's easy. That's going to be 8. And as it turns out, they just keep getting easier. What's the derivative of 8? That's 0. What's the derivative of 0? 0. And what's the derivative of 0? It's just 0. So, as you can see for this problem, if you keep taking the derivative, you're just going to keep getting 0. And that's a certain type of function. Usually you'll encounter that with polynomial functions like this one. After a certain point, you just start taking the derivative and you just keep getting 0. We have another polynomial down here. Y is equal to 8x squared minus 11x plus 3. So once again, they're saying what are the first four derivatives of this function? So what's dy dx? What's d squared y dx squared? What's d to the third y dx to the third? And what is d to the fourth y dx to the fourth? So what is our first derivative? Well, we just use your power rule a couple of times and you get 16x minus 11. Now, what's the derivative of that? That's just going to be 16. Once again, you're just using the power rule. And now this one over here is asking, well, what's the derivative of the last thing that you got? 16? Okay, our derivative is 0 because the derivative of 16 is just 0. And then the next one says, okay, well, what's the derivative of the thing you just got? 0? Oh, the derivative of 0 is just 0. So now you can see how we would be stuck in this loop of getting zeros over and over again, just like we were for the top here. But it takes a little longer until we can finally get up to that stage where we keep getting zeros. And you can see that's because the highest degree of x in this polynomial here is 2, as opposed to 1 as it was in the first example. So the higher the degree of x, the longer it takes for the derivatives to just keep hacking at it until they get it down to a single constant value, which then just becomes 0 after that. So that's how you do a higher order derivative problem like this. Thanks for watching.